Hello and welcome. My name is Xander. I will be your instructor through this tutorial. Now, this tutorial is actually part of a whole course which you can access the first stages for free here on YouTube. Now, in this tutorial, I might mention resources and other tutorials. Do check out the link in the video description, which will take you to the playlist, and also there will be a link to the resources so that you can access and follow along here on YouTube. Now, if you like this course, you found it useful, and you want to take that next step, you can find this course over at Udemy. All the links to the resources can be found in the video description. Now, don't forget, also subscribe to the channel for weekly promotions, discounts, and free course giveaways. A database data type refers to or defines the kind of data a column in a table can store. So each column in a database table has a specific data type that determines the kind of value it can hold. That might be numbers, dates, text, booleans, the amount of storage required, and the operations that can be performed on the data. Going back to our ERD, our database design, moving into the category table here, for example, you can see that the category table has multiple fields. As we work through this course, we'll familiarize ourselves with the different fields, but what is important at this point is that each field is assigned to a data type. So these data types, as I describe, define the kind of data that's going to be stored in each of these columns, in each of these fields. So imagine we were going to add a new row or record into this table. We would need to specify the name. The data that we specify must be a string, so it should be numbers or letters, and you can see it has a maximum of 50 characters. So it means that we can only store in this field up to 50 letters or numbers, for example, and that's something that we can specify here. You can see the slug is slightly more. As you work through the design, you will see that there are different types of data types. So we have booleans, true or false. We have an integer, which is a whole number. We have, for example, date time fields, and over here in the product table we have a numeric. So when we need a number which has a decimal place, we would use a different type of data type to assign that to the field so that we can specifically store numbers that have decimal points. And here, this numeric field, we can specify, for example, how many numbers in total it supports and how many decimal places. Now, although a Boolean is always going to be a Boolean, true or false, and text is always going to be text, every single database management system may have different terminologies that refer to specific types of data. So as we're working with the Postgres database, I do recommend in Google or wherever you like, type Postgres data types, and that should take you to the documentation for Postgres, and here you can inspect and view all the different data types associated to the Postgres database or that can be assigned to fields. Now, there simply just are far too many for us to cover. It would take the next couple of hours for us to work through every single data type. In this course, we are going to be using the more common types or data types that you might see and use in your database, but again, it is worth asking the question, beyond the data types that we are using and you will familiarize yourself with in this course, if there is any other type of data that you're working with, to first of all inspect the data types to try and see if there are any specific data types for that particular type of data that you want to work with. So if you are working with geometric types, you can see here there are specific field types for that rather than using a string field, for example. Or if you're storing data about network addresses, you can see that there are specific field types in Postgres for that. In this tutorial, we're going to familiarize ourselves with common data types, strings, numbers, and booleans. We will identify where there is a field utilizing one of these field types in one of our tables that we've created, and then we're going to create that field within our tables. Now, this will get repetitive very quickly, so we'll work through a few tables and then I will produce the code for the other tables that are required. You can go ahead and inspect them further and, of course, apply them to the database that we're building. Let's focus first on the category table. Here we have a string field, Boolean field, and an integer field. I have named some of these fields incorrectly, but that is going to be beneficial because you're going to then be exposed to the different types of names that might be applied to similar data types. Okay, so the fact is that this name field is a text-based column. So let's move back over to the Postgres database documentation. Let's find this type of data. So that's going to be called character types. So this list here refers to the types or the data types that we can assign to fields in a Postgres database for defining text-based columns. Now there are a few options here, and you can see there is a lot of text associated to it. This is both simple and complex. As your data becomes more critical, as you get deeper into the development process in terms of creating databases for more complex and critical applications, you'll probably end up reading more deeply. For the purpose of our database, let's summarize and specify there are essentially two different types of fields that we can use for text. We have a field which we can then specify the maximum limit of characters that can be stored in that field. So where we have a small amount of text or a specific length, then we can use the varchar, which is a variable length with a limit. So it means that we can store 1 or 2 or 3 characters up until a limit that we specify. Where we require a field to store much larger amount of text, we might typically use the text field. And that's a variable unlimited length. So variable being that we can store 1 text or 1 character or 1,000 characters. Now it does say an unlimited length, but I think the reality is around about 2 gig. So maybe a more appropriate name will be varchar for the string fields that we've defined here within our ERD. This would correlate to what we're just about to build in our database. So I've renamed that to varchar, and you can do that or keep it to string. Now, if we take a look through the other tables, because we are going to build any other field in any other table that has a character field, we will notice that we will require the text field in the products table. So the description here is going to be a much larger amount of text. So we've assigned that to the text field, which supports much larger text. Notice here the name I've described this as a character field. So you may find a varchar named as a string, like we saw previously, or a character field, as well as a varchar. Varchar standing for variable character. If you inspect the other tables, you will find there are other fields where we need to insert or record or save text. We will only be using the varchar or text field. Right, so that's all the string fields in our database design. Let's now take a look at Boolean field. This is really simple. This is Boolean true or Boolean false. That's what's going to be stored here. If we take a look at the documentation, you will find a section on Boolean types. You can read through that, but this field is going to allow us to store true or false. In our design, we've included this field because, take for example the category. We may like to record the Christmas category, but of course we don't want to make that active all year round. So this is active field that we've defined here. We can define whether this category is active or not. That way, when we return categories from our category table, we can return only relevant categories, only categories that is deemed to be active at that point. Active being that the category row or record will have isActive true assigned in that field. So this is just going to allow us to filter out categories that shouldn't necessarily be active at that point of time. And what you will find in other tables is it's going to be a very similar approach. So we have is active here in products, because not all products might be active. Maybe we are creating new products we don't want to be active yet, or potentially we have Christmas or other types of event type products that we want to make active at certain times of the year to be available for purchase. So that will enable us to create that type of setup. Right, so that's the Boolean field. So we move on now to the integer field. So here we're discussing numbers. So there are multiple types of numeric field types. So there should be a section right at the top here for that. So generally, two types of data that we want to work with. We have whole numbers, so integers, and we have floating point types. So that is numbers that have decimal places. So you can see from this list, there's a whole bunch that we can use depending on what type of data we want to store. So if we have smaller numbers, we might use the smaller int. If we have bigger numbers, we might use the big int numeric type. Pretty much all relational database management systems will provide different integer types to optimize storage size and performance based upon the expected range of values. So the primary reason for choosing between them is efficient memory usage and avoiding any unnecessary storage overhead. So simply put, the big int is going to use more storage space. So we can see here 8 bytes in comparison to small int. So if we know that we're only going to use numbers between minus 32,000 and plus 32,000 odd here, then we want to use a small int because that's going to use smaller amount of storage. So you may have also noticed that I've used this generic approach on some of the fields to name the data type. So here it just says Boolean field. It doesn't necessarily match the field type for a specific database management system, but it is clear exactly what data it should refer to. Same here with the integer field. I might include, for example, small integer field, and that will give you a good indication as to what data type to use and to match to our database management system. So here's an integer field. So I'm suggesting at this point it's probably a generic integer. If we take a look at the other fields, where we are using data, we have integer here. I think we're only going to be using integer and the numeric data type in this database. So if we go back here, let's have a look. So notice here, we have the numeric. So that is going to provide us a way of specifying the exact numbers that we want to use. So in our case, we're going to specify a maximum of 10 characters and 2 decimal places. So 10 numbers in total, and 2 decimal places. So this just provides us that control. In PostgreSQL, I think that the numeric and decimal data types, field types, are functionally identical. They both represent exact numeric values with user-defined precision and scale. So typically you would use the numeric or decimal field type when you are storing financial and precise calculations. The only other instance where you might see numeric data is with the foreign keys and primary keys, but we'll take a look and discuss that at a later point. Right, so we now need to create the fields in our table. Now, as I mentioned previously, typically we would probably create all of the fields in our table, specify them in a table in one SQL statement, including all the other properties of the fields. Here in this course, in this module, we're going to build step by step, and at the later stage, we'll take a look at the total code for each of our tables, and then we'll take a look at how we can then apply that to build the tables as a different approach. And that's probably a more common approach of creating tables rather than working through step by step like we're going to do here in this course. The benefit, of course, working this way is that we'll learn more about SQL, the focus of this course. Right, so first of all then, let's first of all inspect the ERD diagram. We will see that there are 2 fields that we need to make first in regards to string fields, and that's going to be the name and the slug field. Right, so first of all, we need to alter table category. So we need to specify what table we want to make changes to. Here we have the sub command now, because we haven't finished this command. We can then go ahead and add a new column. So we use the command add column, we specify the name and then the data type. And here we are specifying a maximum of 50 characters. Notice at the end here we use a comma denoting the fact we haven't finished yet and we want a new line. Okay, so we do the same thing again for the slug field, this time varchar 55, and then we use this semicolon to denote the fact that it is the end of this statement. And then we can go ahead and press enter, and then we've made changes. So at this point, we can go ahead and delete, but let's first of all just inspect the changes. So we use the name of the table category, and there we can inspect and view what we've created thus far. Notice that we've created character varying. That matches the Postgres documentation. If you remember here, we've just created this character varying character type. Now you might want to read this now as this is the type of data that was going to be created, and this is how we can potentially specify it in our SQL code using varchar like you've just seen. Now to drop these tables, simple case of using the alter table, and we can marry that up with the drop column. So we specify what table, and then the command to drop is just drop column and then the actual name of the column. So I'm going to copy and paste this in both at the same time. That's going to run. I press enter twice there, and that should now alter that. So I press up on my keyboard so we can view the previous commands. Press enter, and you can now see we removed those fields. Okay, so that's how to add and remove fields from a table, or alter a table to add and remove fields. Let's go ahead and paste that back in, and we should now have everything set. So that's where we want to be in regards to the category table. Now you can pause at this point and try this out yourself with the other tables that we have. The code is here in the example for each of the tables, so you might just like to go ahead and add all of that in. That's exactly what I'm going to do now. I'm just going to copy and paste this in to all of the tables. So we have this error here that promotion event doesn't exist because I've named that or renamed that to promotion events. So I need to make sure that I change and update all of this code for that. That's going to be a bit of a pain. I forgot about that. So users, so I'm now going to add the user fields. There's nothing new here except for the fact that we've specified different values for the different types of data. So this is just varchar. One thing I did mention was that the product table does have a text data type because that field here, this description, requires a larger amount of text. So we have specified the text field for essentially an unlimited amount of text that can be stored in this field. Once that's done, you might want to further inspect other tables just to make sure that it works successfully. It looks like, for example, in the products table, we now have 3 fields: name, slug, description, varying length fields, and our text field. Next up is going to be the number fields. So there are probably 3 different types of number fields that we're using in this database design. The integer field, the small int. So for example, here in the category, this column level is only going to store the numbers 1 to 10. So I'm using a small int, which is going to be more appropriate in that case. As we saw from the documentation, the small int will store a lower amount of numbers, a small amount of numbers, but it would do so by also allocating a small amount of space for those numbers. In addition to that, you will also see the numeric being defined here. So we're going to add a column price, the numeric field with 10 numbers in total, 2 decimal places. And yeah, I think that's pretty much it. So you can go ahead and run all this code. I'll do 1, and then I will add the rest. So at this point, I have added all the other fields. So I'll just go ahead and check the products now. You can see that in the products table, we now have 1, 2, 3, 4, 5 fields: name, slug, description, category ID, and price. And then no surprises, it's going to be the same for the Boolean fields. So inspect the ERD, make sure that you add all the Boolean fields where required. So here we have one for the category field and the products field. So I'm just going to copy and paste that in. If you prefer to do it yourself, then please do. It's all practice. You can see here, though, that the Boolean field is for the category table, and there's a Boolean field. Actually, there's 2 Boolean fields here in products. But I think that's all the Boolean fields that exist in our database design. Okay. So if we take a look at the products table, we now have multiple fields with different data types, strings, numbers, and Booleans. In this tutorial, we learned how to create fields in our database tables or existing tables. We took a look at some of the common data types, strings or character data types, numbers, and Booleans. And we went ahead and used SQL to update our tables to include the corresponding fields as per our specifications in the ERD diagram.